of the sedimentary rock formation, and what are the criteria for the classification of different sedimentary rocks. Sedimentary rocks are those rocks which form at or near the Earth's surface primarily through the deposition of weathered silicate material by water, wind, or ice. Or it may form direct through the inorganic chemical precipitation from the water or by the precipitation of organic processes. So here in this chart, you see this is the gist of the sedimentary rock classification. So there are mainly these three kinds of constituents of sedimentary rocks. One is the visible grains, which are having a different grain size. Accordingly, the classification of sedimentary rocks has been done. And the other constituent is the precipitates from the water or from the organic debris. So there are different terminology as per their formation and as per their morphology. It has been characterized. So here, before going to the main part, that is the formation and the classification, I would like to inform you about the fundamental things of this distribution of sedimentary rocks, where in this right hand side you can see that the sedimentary rocks covers approximately 80% of the earth crust by area, whereas by volume it covers only 0.029% of the earth and 0.5% of the earth crust. Why? Because the sedimentary rock preservation is very difficult as compared to the igneous and metamorphic rocks. Here you see the distribution of sedimentary rocks through geological time scale, where we find that the age ranges of sedimentary rocks is from Precambrian to recent, and the oldest known metamorphosed sedimentary rocks has been dated, that is approximately 3.8 giga-annum. So this is the date of this oldest metamorphosed sedimentary rocks. Means we can assume that the sedimentary rocks which is formed these metamorphic rocks might have been older than this 3.8 giga-annum. And the earliest sedimentary rocks has been formed when there was the degassing of the earth interior took place during the early formation of the earth. So here we can understand that how sedimentary rocks has been formed, that is through the reaction of this primary igneous rock, that is the mainly basic volcanic rocks with the acid, volatiles and water that forms the sedimentary rocks, ocean and atmosphere. Here in the right hand side, this diagram, you can see the distribution of the sedimentary rocks through geological time scale, where you can see that the percentage of this lava, mainly basic volcanics, is decreasing towards the younger age, whereas the percentage of this sedimentary rocks is increasing towards the younger age. Here you see the relative abundance of major sedimentary rock types, that is the siltstone, mudstone and shale, that constitute about 75% of the whole sedimentary rocks, whereas the carbonate rock constitutes 14% of the sedimentary rocks, and sandstone and conglomerate constitute 11% of the sedimentary rocks. So this is the present distribution pattern. So is it the same? It has been in the past geological time scale. So partly it was true means the distribution of the clastic rocks, that is the sand, shale, are constant from the Precambrian time to the Proterozoic time. Here in this uh, figure, you can see that the distribution of the sandstone and shale is approximately continuous from the Precambrian time to the Neoproterozoic time, whereas there is a minor variation among the different sandstones. For example, that is the Gravity, Arcosic, and the Quartzite. Whereas one important point to notice here, that is the contrast decrease in the jaspilites and their analogs. Jaspilites means the iron stone formation, and there is the increase in the evaporites and limestones. Increase in the evaporites and limestone from the Mesoproterozoic time to the Neoproterozoic time. Now the question comes that why we should study the sedimentary rocks. That sedimentary rocks is only archive which provide evolutionary history of life on the earth. And the second is that sedimentary rocks are the principal repository for information about the paleo-environmental through study the depositional environment of different basin, that is the marine, fluvial, aeolian, glacial, estuarine, and lacustrine. It also helps in knowing the provenance of the area. In that way, we can define or determine the paleogeography of the area, and while during the study of the provenance, we can also estimate the paleoclimatic fluctuation during the past geological time, and which will be helpful to understand the fluctuation or future predictive climatic model. And last, that it hosts noteworthy economic minerals, for example, oil, gas, coal, and radioactive minerals, that is uranium. These are the different environmental tools in the sedimentary rocks which are helpful to determine the paleo-depositional environment. Those are the grain size. Grain size defines the power of transport medium. That then next is the roundness, sorting. These are the criteria of the sedimentary textures. Those constitute the sedimentary texture, which will be more detail explained in the sedimentary texture lecture. So what is the importance of this sedimentary texture, how it is helpful in defining the paleo-depositional environment. Then next point is the cross bedding, which is a primary sedimentary structure. It is also very much helpful in defining the paleo-depositional environment through the determining of the paleocurrent and the other parameters, which will again be detailed described during the lecture of the sedimentary structure. Next, important things that fossils, which is only available archived within the sedimentary rocks, is helpful or much more reliable tool to define the paleo environment. For example, there are the characteristic fossils which define the marine water, freshwater, and terrestrial. In addition to that, there is a different color and chemistry of the sedimentary rocks that define the different mode of origin. For example, the red beds define that this has been deposited in the oxidizing environment, whereas the black shale defines that it has been deposited in the reducing, often deep water environment, and evaporites indicates the arid climate. Now, starting with the sedimentary rock formation, so you all know that there are various stages. Those are involved in the sedimentary rock formation, that is the weathering, erosion, transportation, deposition, burial, and there is lithification, compaction, and sedimentation. Here in this cartoon, you see that this describe ideal model for the evolution of the sedimentary rocks, that the average continental igneous source rock is made up of granodiorite, and after the complete weathering of this granodiorite, there is the mixed weathering product. One is the resistant one, that is quartzite, quartz sand, then clay and calcite. And as per the availability of the space and accommodation, they go accumulate, deposited in a suitable basin, negative relief area. So here it has been shown that quartz, favorable condition for the deposition of quartz sand is the beach, and for the clay is near self, and for the calcite in solution is far deeper in the self, and that forms the limestone, shale and sandstone. So let us see a view very quickly. I will go through the salient points of the different stages of the sedimentary rock formation. So here you see that first stage is the weathering. So there are mainly four types of weathering. One is the freezing, thawing action of the ice. Then onion skin exfoliation weathering that has been developed by the differential heating and cooling of the felsic and mafic minerals. Then there is a chemical and biological activities by which there is a weathering takes place. So the additional thing to understand when we are understanding the weathering process is to the stability series of the mineral that has been given by the Goldich, that is known as Goldich stability series. So here you see that in the lower part, that is the olivine and calcium rich plagioclase, that is the least stable, which have the mostly ionic bands, and in the opposite side, that is the most stable mineral, that is the silica, that is bonded by the covalent bond. So here one important thing we should notice that this stability series is opposite to the Bowen's reaction series. That Bowen's reaction series tells about the crystallization sequences of the mineral, where the olivine crystallizes as 1400 degrees Celsius and quartz crystallizes as a 570 degree Celsius. So it has been considered and approved that since the quartz crystallization temperature is much more closer to the present day or modern basin temperature, so in that modern day basins, that quartz is much more stable than to the olivine. So in addition to that, there is a role of climate and tectonics in the process of weathering. Means there is a high rate of the weathering in the warm and humid climate as comparison to the dry and cool climate. And secondly, if there is an active tectonism, then there will be high rate of weathering as comparison to the stable tectonic area. Here you see that as a product of this differential weathering, there are the different kind of constituents formed. That is by the physical process, this terraceous siliciclastic sediments form. By the chemical and biochemical process, this chemical biochemical constituents form, and as a residual of the organic debris, that carbonaceous material forms, and as a part of the product of the diagenesis, this orthogenic constituent form, and all together with the variable proportion composing of all these four constituents, there are the formation of different kind of sedimentary rocks takes place. So second stage is that transportation. So there are different modes of transportation that takes place in the river, sea, wind and glaciation. And here in the lower part, you see that the transportation of sediments takes place by the fluid. So there are two important things to be mentioned here, that in this part at the sediment water interface, that is the normal bed load, and some particle of the finer size that remains suspended in the upper water column. So these two has very significant role in the formation of the sedimentary rocks and sedimentary structure. So they tells us about the past intensity of the fluid. So accordingly, there are the different equations has been given for the velocity, like the Froude number, Reynolds number, etc., and the other things. So with the help of that, one can determine the paleo-depositional environment. Here in this right hand side diagram, you see that there are different shapes of the grain from angular to the rounded. So in this visual estimation chart, you can see that if the composition is like that, it will be termed as a very poorly sorted, and then if the well-rounded grains are present, that will be the very well sorted. So uh, for the transportation and maturity relation, we can say that the transport time is equally proportional to the maturity. And when we talk about the mineralogical maturity, that is defined by the presence of or abundance of the resistance mineral, that is quartz. So after transportation, there is the deposition. So deposition takes place in the areas of earth crust subject to long-term millions to tens of million years subsidence, resulting in space to accommodate sediments that is not subject to the erosion. Here you can see, and that will be definitely dealt while the dealing with the different environment of deposition, their phases association. So here from left to right, there are the different basins, that is evaporite basin, fluvial basin, deltaic, and submarine fans, etc. So once sediments start to travel from their provenance area, it undergoes a different complex processes at the final deposition site. And when we are dealing with the basin or deposition, then we need to understand that how that basin has been formed. And it is well known that there are one factor that is called tectonism that play a very important role in the basin formation. So here are some categories of the major basin, and in that major basin there are small basins like here in the upper part mentioned that forms. So these basins are, or rather I should say that these tectonic setting are interior basin, intracontinental rift, and Olacogens basin. Second is the passive or rifted continental margin, that is the Atlantic type shelf or slope areas. Oceanic basin, that is the deep ocean floor, and this exclude the transform fault that has a separate category. And fourth is the subduction related setting, and fifth is the strike slip transform fault related setting. So after the deposition, there is the lithification process, compaction and cementation. So lithification is a complex process whereby freshly deposited loose grains of sediments are converted into rock, and lithification may occur at the time of sediments, or means the lithification can occur at the time of deposition of sediments or after the deposition of sediments. After that, there is a compaction, by which there is a pore space reduction, removal of interstitial water, and the initiation of the diagenetic process. Means there is the formation of new minerals like orthogenic, the starting of formation of the chemical solution, and then after formation of the chemical solution, they goes precipitates in the void spaces, interstitial spaces, and those main minerals are calcite, quartz, and hematite. So now I am coming to the sedimentary rock classification. So to classify the sedimentary rocks, there are mainly three end members. One is the terrigenous, second is the allochemical, and third is the orthochemical. So what are the terrigenous? We have already explained that this is the siliciclastic formed by the physical process, that is residual or secondary weathering products, and that is extrabasinal origin. Example of this terrigenous sediments, and that rocks formed by these terrigenous sediments are mud rocks, sandstone, and conglomerates. Second category is the allochemical, that is the product of combination of chemical or biochemical particles. Means that shale fragments are also included with the chemical precipitates. So these may be orthogenic but locally reworked within the basins. Example of this Allo Chemical rocks are fossiliferous, oolitic, pelitic, or intraclastic limestone. The third category is the orthochemical, that is mainly primary chemical precipitation, that is totally formed by the orthogenic, totally formed during the diagenetic process, that is the orthogenic form within the basin, and there is no reworking. So example of this orthochemical are microcrystalline, limestone, chert, and anhydrite. But when there are a mixture of some impurities within this allochemical, so it will termed as a arenaceous oolitic limestone. When there is some mixture of these stereogenous particles in the orthochemical, then that will be termed, or that will be variously termed, but here for example, that is the clay rich microcrystalline limestone. Further, the sedimentary rocks, terragenous sedimentary rocks can be classified broadly on the basis of the grain size. That is, this is the grain size, and this is classification when grain size is more than 2 millimeter, that is rhodaceous, and followed is arenaceous, argillaceous. Examples are conglomerate, which will be seeing here that what is the criteria of conglomerate, sandstone, and the different specific classification of these important sedimentary rocks. So here, first I am dealing with the sandstone. That sandstone is defined as a sedimentary rocks with grains of sand size from 0.06 to 2 millimeter. So basic classification of sandstone is based on the proportion of the mineral grains, dominantly quartz and the matrix. So most common mineral in the sandstone are the quartz, that is monocrystalline. What is monocrystalline? Means there is a single crystal that has been formed by the igneous rock. Means through that is the interlocking crystal pattern that has been developed in the plutonic rocks, and when that is transported, deposited in the basin, so that is the monocrystalline rock, and it is identified under microscope with the help of measuring the extinction angle, that this monocrystalline quartz give the straight extinction, whereas this polycrystalline quartz that has been, or it has also termed as a strain quartz. So this has been developed during the high pressure and temperature conditions. So there is a development of various crystal within one quartz grain. So this is termed as a polycrystal, and this gives a uneven extinction under the microscope. So this quartz is the most abundant grain of the sandstone. Then next dominant grain is the feldspar, and as per the stability series, that potash feldspar is much more resistant as compared to the calcium feldspar. So here the sanidine and microcline are the dominant one feldspar in the sandstone. Then next constituent is the rock lithic fragments. So all kinds of, including limestone and dolomite fragments are present, and that is less stable. In addition to these principal components, there are also some heavy minerals present within the sandstone. So here, this is the classification that is the most accepted and convincing given by the Petitjean. So here in this diagram, you see that there is mainly two things. That is the one grain, that is quartz, feldspar, and lithic fragments. The other criteria is the percentage of the matrix. When there is the matrix percentage from 0 to 15%, so that will be termed as a arenite. And when there is a quartz grain percentage more than 95%, it will be termed as a quartz arenite. And if it is 95% feldspar, it will be termed as a arcosic arenite, and similarly lithic arenite. Within this domain, as per the percentage of this quartz, feldspar, and lithic fragments. There are a different classification has been given in this quartz arenite field, that is the sub-Arcos, sub lith arenite, Arcos, lithic Arcos, etc. When there is the matrix percentage increases from the 15%, this rock will termed as a vacay. So accordingly, when there is a high abundance of the quartz with the matrix percentage more than 15%, it will be termed as a quartz vacay. When there will be the feldspar percentage more than 60%, it will be termed as a feldspathic vacay. When there is a 50% litharinite, 50% feldspar, that will be termed as a gray vacay. So here these are some field photographs of the different type of sandstone, that is the quartz-arenite, Arcos, and the gray vacay. So here you see that sandstone composition that indicates the provenance area and the tectonic setting. So here in this ternary diagram, when there is a high abundance of these quartz grains, that depicts that the rock has been originated from the provenance of the stable continental craton. And when there is the percentage of quartz and feldspar only, that is the very few percentage of the lithic arenite, means the rock sandstone has been developed from the continental rift system. Whereas when there is the percentage of quartz and litharinite as well as few percent of the feldspar, so this has been developed from the provenance of continent-continent collision or recycled origin or the continent volcanic arc collision. When there is a very few percentage of the quartz, approximately 30-40%, but the high abundance of the lithic fragments and feldspar, so the sandstone has been developed from the volcanic island arc setting. After the sandstone, now proceeding towards the conglomerate. That conglomerate is a coarse-grained silicic clastic rock with muddy and sandy matrix, and where the gravel is more than 30%, then only we can term that rock as a conglomerate. And the provenance can easily be determined with the help of the composition of different class. And what are the different types of conglomerates are that conglomerates are the rounded clast in sandy matrix, and Brachia is having the angular clast in sandy matrix, and dimictite that clast in muddy matrix, and one term that is tillite. When we are able to be sure that the clast is of the glacial origin, then we can directly use the term tillite for that kind of conglomerate. So these are the different classification of conglomerate on the basis of texture, composition, and the source. So on the basis of texture, that there is the grain or clast supported will be termed as an orthoconglomerate. When matrix or mud supported conglomerate, that will be termed as a paraconglomerate. On the basis of composition, when clast is composed of several composition, that will be termed as a polymictic. When the clast composed of 2 or 3 types of composition, that is the oligomictic component. When the clast are of same material, that is the monomictic conglomerate. When the pebbles originated within the basins, one can be sure that pebbles have been originated from the basin only, and there is no any pebbles or clast are from the outside of the basin, then we can term this conglomerate as an intraformation conglomerate. And when there is pebbles originated from the outer side or extra basinal in origin, then that will be termed as an extra formational area. In the Indian stratigraphy, there are 2 examples of this category, that is the Pulivendla conglomerate in Kadapa Basin are an example of intraformational conglomerate, whereas this Gulcheru conglomerate are an example of the extraformational conglomerate. Here these are photographs of the oligomictic conglomerate and the polymictic conglomerate where the different types of clasts are present, that is the quartz, jasper and basic fragments. After that, moving to the shale or mud rocks. So this shale or mud rocks is composed of silt or clay sized particles, and the dominant minerals are kaolinite, smectite, illite. Also, quartz, feldspar, and carbonate organic matter are associated or present within this rock, but the dominant are kaolinite, smectite, and illite. The composition of this shell may modified by the diagenetic process. It has the variable color, that is gray to black color, that indicates the presence of organic matter, and red, brown, yellow, green color of this mudstone indicates the oxidation state of iron. So in addition to that, there is one another character of mudstone is or shell is that it is characterized by feasibility plane. So because of the parallel orientation of this elongated clay minerals, this show or exhibit this feasibility characteristic. In particular terminology, there are one kind of shell is that splintery shell that is characterized this feasibility plane, and the deposition of this mud stone takes place under the low flow regime and under weak water current, that is in the offshore and in a lagoon. Shells are highly porous, but due to the surface tension phenomena of water and extremely fine intergranular spaces, shells are impermeable. So here, how to study the clastic rocks? That first one has to identify the clast. Clast may be of this larger size or maybe fine gravel or granules. So that clast is bounded by the matrix of this finer grain, and again this matrix is bounded by the cement, that is the dissolved substance that bounds the sediments that may be calcareous or siliceous. So after the category of this terraceous sandstone, coming to the second category, that is the Allo Chemical category constituents, that is carbonates. So in the carbonates, when there is a more than 50% primary carbonate minerals, that is limestone and dolomite is present, then only that rock is termed as a carbonate rocks. That carbonate rocks are excellent indicators of the depositional environment and integral to study of the past environment and the Earth's history. So this is an important reservoir for oil and gas. So how carbonate sediments originate? That primary carbonate sediments form as a basic particles in shallow marine environment, secreted as shells of invertebrates and algae. In this particular kind of the situation, that it precipitates in the warm water tropical area from 30° north to 30° south latitude, in the shallow shelf within the photic zone, mostly between 10 to 20 meters, and also accumulate in the deep water as a pelagic ooze. It also precipitates in the organic methodology by directly from the precipitation of the seawater, and it can also form in the continental setting, that is lacustrine desert, oil and springs. So here in this diagram, it is showing that the subtidal part of the sea that produces most of the carbonate sediments, that is termed as a carbonate factory, and from there carbonate sometimes transports to the deeper part as well as to the seaward side also. So these are the different constituents of the carbonate rock, that is micrite, sperite, allochems and biolithic elements. So micrite is a lime mud and its size is less than 0.004 millimeter, and this is largely remains of the fragmental algae and also chemical precipitate. Appearance of this micrite under microscope is that it shows that sub-translucent appearance, so that one can differentiate between micrite and sperite. So micrite implies the deposition in low energy environment, just like in the terrigenous mudstone. Whereas this sperite, that is the crystalline carbonate material, which size is more than 0.004 millimeter, and it forms by the precipitation or recrystallization during diagenesis. This sperite formed in interstitial pore spaces of the carbonate sediment, and when there is a sperite present, so it indicates the void spaces, original void spaces. So with the help of a study of this micrite and sperite, the one separate kind of study, that is the porosity variation pattern within the carbonate rocks in the different a variety of carbonates from the Precambrian to the Cenozoic can be done. So this porosity study is very much helpful in the oil and gas industry. Next constituent is the allochems, that is transported chemical or biochemical precipitates, that is fragmental material, and it includes intraclast, ooliths, paloids, and bioclasts. Then another constituent is the biolithic elements, that is formed by organism in situ and bound together by precipitated material. So in the classification of the carbonate rocks, there is a major or mainly these four constituent has been considered, and according to the different or variation of this constituent, the different terminology has been used, and definitely the variation of this different this constituent indicates the different kind of environment of deposition. So here one specific kind of allochems, that is the ooliths. So this oolith is the concentrically laminated carbonate structure, and its diameter is less than 2 millimeter, and it is thought to be abiogenic in origin, and its layer precipitated onto a grain during wave agitation. Means how weed forms. So there is one nucleus. First, there is one nucleus, that is either rock fragments or skeletal fragments. Then there is a subsequent deposition of this lamella, concentric lamella takes place. So the one important character of this fluid is that can be observed only under the scanning electron microscope, that if there is a tangential aragonite needles in the weeds is observed, means that weeds is of modern age origin. Whereas if there is a radial fibrous calcite is observed in the concentric lamina, means that is it of ancient age, means the older age. Similar to this point, there are some other allochems, that is the Piezolites, that is same as oolites, but its diameter is more than 2 millimeter, and the other allochems are oncolites, that is the spheroidal stromatolites, whose diameter is more than 1 to 2 centimeter. Another allochems is the paloids, that is fecal pellets. Size of that paloids is silk to fine grain and sand size carbonate particle with no distinctive internal structure. So this formed by the process of excretion in the protected shallow water with minimal subsea cementation. So that indicates, means abundance of these paloids indicates that there was the high number of faunal association with low diversity, and all those faunal association are of filter feeders. So on the basis of these constituent, there are two main classification has been proposed for the limestone. One is the folk classification, that depends on the variation of our presence of this spherite, that is cement, and the micrite, that is the matrix. So there after this cement and matrix, what quality of this allochem or clast is present, so accordingly the terminology will be used. When there is the intraclast, that is the intraspherite with bounded by the spherite. When there is the intraclast bounded by the micrite, it will be termed as the intramicrite. And when there is a weeds bounded by spherite, micrite, accordingly the term will be used. And for the biological fragments and the for the paloids, here in this side, the one category is that is the floated micrite, and the one category is that disc micrite. So this disc micrite is characterized by the fenestrate or bird's eye or the window type of structure. So this particular disc micrite is a characteristic of the tidal environment. The other character is that biolithite, that is the reefs or stromatolite. So the another classification is the Dunham classification. So that is mainly based on the texture and which is described in terms of the proportion of carbonate mud present or the framework of rock. It means the mud versus grain. So here these are the characteristic points to understand the Dunham classification of limestone, that when the depositional texture is recognizable or not, and when the original components were bounded biologically or not, means that original components not bound together during the deposition, and when the original components organically bound during the deposition. Then the other criteria is that mud bearing versus mud free sediment. So here this is the mud contains, and then another category is the lacking of the mud. Then there is the mud versus grain support, when there is the less than 10% grain. So here from the top you see that the depositional texture is recognizable under that category when the original components were bounded during the deposition or not. So these categories that were not bounded during the deposition and after words in the subsequent phases of deposition, that has been bounded. So under that, on the basis of the presence of mud and lacking of the mud, this has been characterized as a grain stone. And when there is a less than, then this is the mud supported, less than 10% grain is the mud stone, more than 10% grain is the vacay stone. When it is totally grain supported, that is the vacay stone. In the next category, when there is a more than 10% grain of a specific character is more than 2% millimeter size of the clast. So if that is matrix supported, so that is the float stone. If that supported by more than 2 millimeter component, that is the root stone. So here you see when in the original components organically bound during the deposition, so that is collectively termed as a bound stone. But when there is a differential structure, so if there is a baffle or this kind of branch structure moving in one particular direction, so that will be termed as a baffle stone. When there is a parallel this kind of a structure, that will be termed as a bind stone. When there is a rigid framework developed, so that will be termed as a frame stone. When we are unable to define the depositional texture, so that will be termed as a crystalline. So after the allochemical or second category, the third category of sedimentary rock is the orthochemical. So the difference between allochemical and orthochemical, again I am repeating that the allochemical is a combination of the cell fragment as well as the chemical precipitates, whereas in the orthochemical that is only the chemical precipitates. So this orthochemical category is dominated by the limestone and dolostone of precipitate origin only. It also includes evaporites, chert, and iron formations. And this precipitate from marine or non-marine waters due to chemical changes. So let us see the characteristic of these rocks which comes under this category. So that is one is the evaporites. So these rocks are formed within the depositional basin by precipitation of ions from chemical substances dissolved in the sea or lake water, which becomes more concentrated when water evaporates. Evaporites mineral in the sedimentary rocks are forms of calcium sulfate either as gypsum or anhydrite, and gypsum is the hydrous form of the mineral, that is the calcium sulfate, and two molecules of the water. So calcium sulfate is precipitated from the seawater once the evaporation has concentrated the water to 19% of the original volume. Then only that this evaporites will form. Next rock is the halide, that is NaCl, that precipitates out of seawater once it has been concentrated to 9.5% of its original volume. It may occur as a thick crystalline bed or as an individual crystal that have a distinctive cubic symmetry. And the surface exposure of halide can be found in some arid regions where it is not removed by the rainwater. Why? Because this is the high soluble NaCl, so it may generally dissolve by the rainwater. So only we can found in the some arid region uh, where there is a very low rainfall or scarcity of the rainfall. Naturally occurring halite is a rock salt. The other rock type falls under this category is the chert. Chert are fine-grained siliceous sedimentary rocks made up of silt-sized interlocking quartz crystal, that is microquartz, and chalcedony, that is the cryptocrystalline form of the silica, and composed of very fine intergrowth of the quartz and monganite. Beds of chert either form either as a primary sediments or by the diagenetic process. The next category is the sedimentary phosphate. So rocks with concentration of phosphate 5 to 35% are called phosphorite. Mineralogically, phosphorite are composed of francolite, which is a calcium phosphate. And in some cases, phosphate is the form of coprolite, which are the fossilized excreta of fish or animals. Apatite with high relief are generally found or common heavy mineral, that is a form of phosphate is found as a heavy mineral in the sandstone, that is of inorganic origin. Then sandstone, ironstone, sedimentary ironstone formation, that sedimentary rocks that contains at least 15% iron are referred to as a ironstone or iron formation, in which the different forms of the iron are oxides, hydroxides, carbonates, sulfides, and silicates. So these iron-rich deposits can occur in all types of depositional environment, and on the basis of their different occurrences and other characters, this is termed as a hematite, goethite, and pyrite and siderite. So this is the concluding slide where it is showing the classification of the sedimentary rocks given by Nichols. So there are mainly two types of sedimentary rocks, that is clastic, non-clastic, and under the clastic these are the different category, that is the volcanic clastic, terrigenous clastic, and carbonates. Carbonates can formed by the clastic inputs or as well as by the non-clastic inputs. And here these are the different mineral principal components of these rocks. Thank you. So there are few things that has been in the chat box, that we are missing the banded iron formation is also a sedimentary deposit. Most of the iron ore deposit are banded iron formation origin. Yes, it is true. And the other is the crystallization temperature for olivine are above 15 degrees Celsius. Yes, it may be true, but this crystallization temperature in a different book that is given a different temperature. So from some book where I have taken that range from 1400 to maybe some 1500. So I took it as a 1400. So in addition to that, if anyone has any thing to ask, then please let me know. So since this was a basic topic, so just I went through, and now if any clarification discussion is required, so we can do now. So please. Meaning of orthoquarsite. So there is one question in the chat box, that what is the meaning of orthoquarsite? Okay, so quartzite is the term, metamorphic term, means if quartz is metamorphosed, that is the quartzite. And what I feel that if there is some uh, participation of the chemical solution, then that will be termed as a orthoquarsite, what I feel. And moreover, I want to say that this kind of terminology is being followed in a different textbook or publication. Different terminology for the same kind of rock is being followed. So most important is that that what is the constituent is present in that rock, that needs to be understood. How conglomerate beds bands are formed. So ma'am, uh, conglomerate beds formed. So there are steps like the formation of the other rocks. So there are steps like, first is the weathering takes place in the regolith part. So there is the development of this clast. So definitely when there will be the weathering takes place, if any particular horizon or surface is exposed for a longer geological time interval, so that will be exposed for the variation of physical and chemical fluctuation. So as a result, then there will be some gradual developments of the cracks, and then that will be formation of the clast, and subsequent there will be the removal of the least stable minerals from that site, and in that way that classed in situ get deposited. So that will be the intrabasinal formation of the conglomerates. In other way, during the subsequent course of time, if those class can transported by any physical media, then that will get deposited in the negative or negative relief area, that is called basin. So that there that will be the conglomerate, extrabasinal conglomerate will be formed. And if there is a periodical change in the supply of the sediments, then there will be the different bands will develop. So in that way, banded conglomerate or the conglomerate forms. So in addition to that, if you ma'am, if you want to add something, then you please add. Apesha ma'am. Hello.
Thank you,
Hello.
sir. Thank you.
Yes, Kapesha ma'am, am I correct or not? So what is the further explanation about these conglomerate beds? So if anything you can add, then you please add.
Yeah, when I go to the field, when I see this conglomerate bands or beds in the field in the different formations,
Okay.
so I keep wondering how these conglomerate beds came into being into this. So that is
Def-
why. Anyway, I
so
understood. Thank you so much,
so
Bharti.
so so definitely, I went very quickly in the classification of the conglomerate. That conglomerate is of the in situ origin, or it may be transported. So when there are another field criteria to identify the conglomerate, whether that is transported or not. So for that, there will be mainly a different kind of clast which indicates the different provenance or different source rock. So means the clast are coming from the different area. One is coming from the metas. For example, one in one basin, one side there is the metamorphic terrain, in the another side there is a igneous terrain. So there will be the clast of the quartz clast, as well as if metamorphic high grain granulite rocks are there, or schistose rocks are there, so we can get some clast of those metamorphic rocks. So in that way we can say that these conglomerate are the transported one, that is the extra basinal or extra formational, we can say. If there is the monometric conglomerate, means there is the only single one conglomerate is there. For example, if we will talk about the basal conglomerate at the base of the Gondwana sequences, and in the most of the part Gondwana is developed over the Archean basement. So we have an idea that in particular terrain that there is this kind of basement only, and the quartz class or some class that has developed in that place only, or of single composition, then we can be sure that this class has developed in situ, not transported intraformation.
Excuse me, sir. Again, uh, can we also date from this conglomerate bed? Can we do a age dating from the conglomerate bed?
Dating.
Yeah. For
Dating.
example, see, I I noticed conglomerate bed in between middle Buban and upper Buban. In
Middle
between this.
Bhuban and upper Bhuban. Yes.
So, so it is there in between these two formations. So I also wanted to know the what is the age of this conglomerate band. So how do I go for that dating?
So, ma'am, it is very well known, but for the dating, either we can follow those biological dates with the help of the fossil, or with the help of some geochronological, means isotope dating. So,
Okay, sir.
which method you want to apply there?
Yeah.
Because the Bhuvan formation, what I know that itself, it is a very complex geological unit, because it is only divisible on the basis of the percentage of the sand shale ratio, isn't it?
Yeah. No, there are also fossils. There
Fossils,
are also
but
fossils which are
what I have read the publications from this either Ralte or RP Tiwari et al, what they have published, the mollusk fossil from those areas, all those are wide ranging fossils, and with the help of some fossils that is correlatable with the Burma area. So means Asia Pacific affinity, they have indirectly fixed the age of those age range of those fossils. So I think that is mainly based on this mollusk fossil. In addition to that, there are some reports of this uh, uh, mm, uh, some microfossil reported from this BSIP people. So they have also done some from near the Isol and this area. So they have also dated that this early to middle Miocene. But this is my personal opinion that for the standard publication, those dates are not very much acceptable. So they have done those nanoplankton study. What I know.
Yeah, it is a bit difficult.
It is a very,
Since I
very,
can,
very bit difficult. Even
yeah,
the lateral tracing continuity of those conglomerates which you are talking about, that is also difficult. So for that, I think some another tool, like for example, this thermoluminescence or whatever that method, that can be used if the suitable sample we can obtain.
okay, okay, yeah. But for your information, sir, I do have also some publications from Mizoram, from Bhuban, Upper
Yes,
Bhuban
yes,
formation.
yes, yes. I have
Yeah,
seen, ma'am. So one publication is from Ajmi Shahab. That is your planktic foraminiferal biostratigraphy they have done, and planktic foraminiferal zone. That is, I think N14 to 15 or whatever it is given. That sample was taken from the Kolasib area.
yes, yeah, Kolasik.
Yes, Kolasib. So that I have read.
Isol
So
also, from Isol also.
Isol as well as Kolasib area
With
for that
PhD
publication.
producer and yeah.
Yeah, for the publication given by the Azmi sir. So
Yeah,
in
it
that
is
publication,
Dr. Raju and Nazmi, yes.
yes, 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 yes. So they have reported some UV geranites and some UV geranites, I think.
Yes, and Globigirina also.
Yes,
And
Globigerina also.
nanofossils also in micropaleontology. That is
Uh,
from Isol.
yes, micropaleontology. They
In
have the
micropaleontology journal.
micropaleontology journal.
Yes.
So,
On
ma'am,
nanofossils.
I have not seen that publication, or I think now I am forgetting. So, definitely, I would be happy if you will share that publication with me.
Okay, I'll surely do.
Uh,
Thank
so,
you. Thank you.
okay, ma'am. Thank you. Thank you. And any other? So, one question is from Dr. P.K. Nayak. That is, banded iron formation is one of the important sedimentary origin. Perhaps we have missed that in which division BIF will come. No, sir, we have not missed that BIF. That is of chemical origin. So at the last, you can see my PPT at the last point when we were describing the category orthochemical, means the sediments deposited exclusively through the chemical precipitation. So in that category, when I described the evaporites, halide, chert, and at the last that banded iron formation also I discussed. So again I am repeating, sir, because all those things were the very basic thing. So I thought that during the classification slide only, I gave a bit some more time that what are the criteria for the sandstone classification and for the this limestone classification by Dunham and the Fogg. Otherwise, I thought that it was a very basic one, so I didn't discuss in detail on that. So I have not missed it, that, sir. Okay, next up.
Sir, okay, thank you.
And the other one question is Abdul Rahman. He is asking how to differentiate between pebbly sandstone and conglomerate. Sir, it is very easy, as you have used the term pebbly sandstone. So sandstone is the suffix, like what we use in the sandstone classification, that arcosicarinite or lithicarinite. So main thing is that arenite arenite means grains, means maximum number of grain are present, matrix are less. So whichever is the suffix one, that is the dominant one. So here your sandstone is the dominant one. but only few pebbles will be present. So that will be termed as a pebbly sandstone. However, as I discussed that when we will use the term conglomerate, when the clast are pebble size clast are more than 30%, then only we can use the term conglomerate. In the one question is from Suman Dev Burman that in the Chotanagpur Plateau fringe region, which type of sandstone will form? So, sir, if you will exclusively fix the condition that at the fringe of the Chotanagpur Plateau region, then there will be the combination of this feldspar or these quartz grains. If there is not much more travel has taken place, then there will be a least stable constituent will also present. And if you will consider that that has traveled a significant amount of distance, then the least stable mineral will get removed. Then the quartz arenite or arcosic or Arcos will form at the fringe of the Chotanagpur Plateau. When I discuss the ternary diagram of the sandstone, there you see that model depicts that when there is the different percentage of the different constituent, and accordingly they denote the different kind of orogenic setting, where that is the continental rift setting or the volcanic arc setting or the continent-continent collisions setting or the cyclic orogenic setting. Okay, sir. Shuman Dev Burman sir. So one question is there that how to distinguish between Arcos and Graveke. So it is very easy. Arcos and Graveke. In the Graveke, when we will use the term, when there is the 15% matrix and 50% Arcos and 50% lithic fragments, then we will use the Graveke, whereas there is the less than 15% matrix and more than or um, uh, 50 to 65% Arcos is there, then we will feldspar is there, then we will use the Arcos. So it is very easy, that classification given by the Petition, so that is very easy convincing. So which whatever the kind of sedimentary rocks, either it is Arcos, Graveke, lithic arenite, whatever, so that can be easily categorized, classified. And one additional thing I want to mention here, that